Hello everyone. So today we are going to solve this Leetcode problem number 868 binary gap. So this look like a very simple binary problem, but if you don't understand the pattern, you will overthink it, right? So in this video, I will explain the problem in detail and will show the pointer movement in very good way so you can easily understand. But I will also use this problem into Java, right? And I'll show the cleaner bit manipulation trick so you can understand clearly. So let's get started. This is the problem we have. I'll show you the constant also. So constant is like this: n is greater than or equal to 1 10 to the power 9, right? So basically the question saying that we have given a positive integer n, right? And this n could be greater than or equal to 1 or could be less than or equal to 10 to the power 9, we can say. So basically what is our task? It is saying we have given positive integers and we have to find and return the longest distance between any two adjacent ones in the binary representation of n. If there are no two adjacent ones, return 0. Okay, so two 1s are adjacent if there are only zeros separating them, possibly number of 1s, the distance between two 1s is absolute difference between their bit position, like that it is saying. So I'll explain you here, give me a second. So we know that we have given and we have given, right? And our task is to very first thing is we should convert into binary, correct? So very first thing is we have to convert the binary, and in second step once we will convert the binary, this n into binary, then we have to find the what you call the maximum. We can say find the maximum. It is saying find the longest distance, means the longest or the maximum distance, right? Once you find the maximum distance between two consecutive, means you have to return two consecutive 1s, right? Means we have given n, we will convert into binary and then we'll find the maximum distance between two consecutive 1s, right? So what is the important thing here is we are not counting zeros, we are only counting what 1s, right? So it is saying find the maximum distance between two consecutive 1s, right? It means if there is a 0, we will not count. Okay, we are measuring the distance between two 1s, right? 1s. So let's suppose we have given 22, right? Let me show you. So let's suppose we have 22 given as a n equal, right? It means very first we say the binary of 22. So binary of 22 is nothing but, if you remember, 8 4 2 1, and this will be the 16, right? So when we need to add, right, this thing, it will say okay, let's go with this is 0, this is 1, this is also 1. So now 4 and 2 is 6. Then we'll say okay, we will not count this one. So we'll say 16 and 4. 16 4 is 20 and 2 22, right? So this will be our binary number for the 22, correct? Once we will find this one, so let's index this as a 0 1 2 3 4. So this is our index. So the position of I will look like, let's suppose this is our index on this one. So position of this where we have 1, right? So we'll say position of 1. Let's say we have 0 2 and 3. So when we are saying 0 means at here, 2 means at here, and 3 means at here. So these are the position where 1 is there, right? So if we want to compute the distance, so how we'll compute? So let's compute the distance, right? So distance is, let's compute the distance. So very first, distance between 0 and 2. So if you say from here to here, distance is 2. Then we'll say between 2 and 3 is 1. So what is the maximum? So maximum is 2. If we'll take from here these 2 and 1, what is maximum? So 2 is the maximum. So this is the output. This is the whole output we can say we have here for this problem. It's very easy. So you don't need to get confused, right? It's very easy. So this is a, and we have given, so very first, if we want to convert this binary to string, we have in Java is two binary string method, where integer.toString if you'll do, and you will pass the integer n, you will get the binary representation, right? It's easy if you want to convert into binary string, right, to any integer. Then we'll take two things, index will take and the gap will take, okay? And we'll start from index 0 and we'll keep moving till the length last, right, of the given binary, right? Then if we will check that binary char at I is 1, and if the last index is not equal to -1, very first we will find the gap. How will find the gap? So when you start with the 1, right, and the last index is not equal to -1, it means for the first index, let's suppose it was 1 0 1 1 was there, right, and then 0. So let's suppose when the index is at here, right, I, so when we'll come in this loop, right, we'll check this 1, it means we will not go in this loop, we will update our last index. Last index will come here, okay? Then similarly we'll keep ahead, 0 is there. When we come here at 1, right, so we'll check that, okay, I value is 2. So at I equal to 2, we got the value 1. Then last index is equal to 0. So what we will do, we'll find the gap. So we'll say gap, basically starting it is 0. So we'll say 0 minus last index is nothing but, so currently we have 2i and index is 0. So we'll get the max gap equal to 2, right, because this is 0, right? And then we'll update the last index. So now the index will be updated to this one. So last will move from here, it will come to here. Then when we go to the next time we will reach here, right? So current value is 3 and last index is a 2. So we'll get 1, right? So maximum gap was now is 2. So we'll say this will give you 1. So 2 and 1, gap will be, max gap will be 2 only. And so we'll keep doing that and we'll finally will return the gap, we will return in the last, right? If you see here, it means if we talk about the complexity, right, let me clean it. So for the time complexity, right, we are traversing the binary from 0 to n, right? So and we have this is just maybe it's not a what you call we are checking all the value, right, all the binary representation, and for this thing in Java it becomes O of log n basically, okay, because this n is completely different than this, right? Because if this is n is, let's suppose we have is 22, means our code is not going to 22, right? It going to some value. Let's suppose if this is m, right, if this is m and this length is n, so this m will be always greater than this n, correct? So do not compare this n, right? Means this n, if m equal to 22, this is m, right? So on that basis we will say this loop will go in O log n, not this n. Okay, so don't get confused. Then we'll talk about the space complexity. It is also taking O of log n, because we are storing here on the variable. We can say basically when we do integer dot to binary string, we'll get O log n in a space and time complexity. But this code works perfectly. We can do better. How we can do that better? We can use the bit manipulation concept, right? We can say basically, if you want to optimize, so instead of converting this, right, string, converting this n into a string, you can just use n and 1, right? This n and 1 we will do, and to check last bit. So when you use this, then you will, to check last bit, what you need to do, you can use directly n and right shift of 1 bit we can take. So when we do to shift right bit, we can say, so what we can do here, we will not do these things like conversion. We'll take only the last index, and then we'll take a current index, and here we can use a while loop, and we'll check if n and 1 is equal to last bit is equal to 1, right? In that case, if the last index is not equal to -1, we will find the gap. But here this will be our current index and this will be our last index, right? Then, and current index we will start from where? At 0 we can start. Okay, I will start from 0, we can say, or we can give the name current index, and similarly we'll update the last index equal to current. And after that, once you will come from this one, right, you know that we have to increase the I. It means n is equal to greater than equal to 1, then we'll say current plus plus, and finally we'll return the gap. Let me show you how to do. Yeah, so this code is also working fine. Let me show you. So what I'm saying, if we can optimize like this, let's suppose we are not going to convert, we will take only the current index out, right? And we'll say if while, until the while is greater than 0, we check the last bit. If last bit is equal to 1, it means we'll check we will come in here and we'll update for the first time, right? We'll check the current bit if it is equal to 1, right? Then we'll come here and we'll update the last bit as a 0, right? Then we'll keep going ahead, right? Because each time we are doing current plus plus. If this is not if the bit is not equal to 1, means we are checking each bit, right? So basically we want to inspect the bit directly, right? So to check the last bit, we will use n and 1 equal to 1, right? Then only will come here. Otherwise what will happen, we will go to the, we are using the right shift here, so we can move ahead, right? And then we'll understand that current plus plus will do. So current is starting from the 0, so we'll move to the next one, right? So when we'll move to the next one, we'll find 1. Then we will say, okay, last is not equal to -1 because we have updated, let's suppose here, right? And we will get some index currently. So when we'll reach to the second one, it means this is current index is at 2, last index is at 0. So we'll get the gap is equal to 2, like that, right? Similar to that. So this is what we have to do, guys. Okay. So in case if you have any doubt, you can bring me in the comment box. Now the thing is, you will say why this is better, because there is no extra string we are using. As you can see, we are not getting convert. If you are see the previous code, we are converting this one into binary, right? But in this case, we are not converting in any extra string, right? and that save more memory efficiency happens, because we are not converting, means time is not getting consumed, it is not taking extra spaces, right? So memory management is become efficient here, right? And this is actually a real interview type. So if you are in the interview, I will suggest use the bit manipulation trick like this, okay? And so that you have a real bit in the understanding, okay? So this is not about the binary tricks, guys. It's about tracking the previous occurrence, measuring distance, updating maximum, like that we have seen, right? Maximum gap, right? That's it. If you recognize this pattern, or many other binary problem becomes easy for you, okay? So what the common mistake people do, right? Very first, that people used to find that, okay, what is the what is the concept here? Are we going to do counting zero instead of index difference, right? So never do that. Like you should not do counting zero instead of this index difference. This is an index difference problem, not the counting zeros. Forgetting to update the last index. So never forget the last index. If you will do this, you cannot do the common mistakes, okay? And also always initialize with the last index equal to -1. It's very important. So you can start with the last index from 0, right? It will be easy for you. So whenever you see the maximum distance between same element, right, think that we have to track the previous index, right? If we track the previous index, right, then we have to compute the distance, right, and then we have to update the max, okay? This is very simple, so don't complicate these easy problems, okay? So that's all I have, guys. In case if you want to learn Java or DSA, you can join my online classes. So you can ping me from the given WhatsApp number. You can join from there. Thank you, guys. Thank you for watching this video. I'll see you in the next one. Bye bye.